chapter 2, the force standard, a box is being pushed up an incline to a height of 1.0 meters. How hard would I have to push the box to start the box moving up the incline if I'm pushing parallel to the incline? We have the mass of our box. The coefficient of static friction is 0.30. F equals the coefficient of static friction times the normal force. We have our constant G and angle theta. First, we want to draw a free body diagram. We have our y-axis and our x-axis here. And then this is our box. And we want to draw the forces acting on the box. We have the normal force, and then gravity, which is negative. We have the friction and the force applied. And we have our angle theta here. The y-axis is the cosine theta, and x-axis we will use the sine of theta. So then you want to find the sum of the forces for your y and x directions. So the sum of the forces for y is normal force minus gravity and the cosine of theta. We know the gravity and we know cosine of theta, so we're going to solve for n, and n equals the m times g times the cosine of theta. So now we solve for the sum of the forces in the x direction. We have the force applied plus friction minus gravity times the sine of theta. We know all of these except for the force applied, so we solve for Fa. Fa equals the coefficient of static friction times n, and n was here, so mg times the cosine of theta, plus the mass times the g and sine of theta. So then we're just going to kind of rearrange it where Fa equals mg times the coefficient of static friction times the cosine of theta plus sine of theta. And then you just plug in what you know. You have the force applied equals 425 kilograms, which is the mass, times g, 9.8 meters per second squared, our cosine of 15 degrees plus the sine of 15 degrees, and you get Fa equals 2,285 newtons. So a force that exceeds 2,285 newtons would start the box moving up the incline.